So, welcome to my talk about app security and securing apps. I would like to give you a little bit of context of, or not. Yeah, why I'm doing that. So, actually, I'm the CTO at Scalable Capital, which is a recent fintech startup in Munich. And we are providing risk-managed ETF portfolios and do automatic rebalancing and management of that for you. How is it relevant in that context? It's relevant because we can only do that because we are a regulated financial institution in Germany and in the UK. And as such, we have to provide certain guarantees and certain documentation to the regulators about our security setup. Not only about our apps, but also about all our other platforms. This is an important part, the regulatory thing, but it's also an important part for the trust of our clients. Losing trust is very easy, and gaining it back once something happened and once you were in the media with a security breach can be fatal for a startup like us. So security, there is also, it's a function of the actual security, objective metrics, of the perceived security, and also of all the parts that are involved in the system, back-end, front-end, the processes, and the apps. Today I'm just going to talk about the apps, but when you think about security, it's really important that you don't forget all the others. A little bit overview about this talk. First, I would like to discuss a little bit what it actually means, security. What are we talking about here? And then I'm going to pick two particular important topics out of the whole space and talk about secure communication and data safety. And also how we evaluate whether our apps are actually secure. I will conclude then the talk a little bit with how you embed this into your software development process, how you actually build a secure organization, and also give you some pointers on how you can continue. So, secure apps. It means your sensitive data is safe, could be one thing. You don't allow unauthorized access to resources, an API, or whatever kind of important thing. It's impossible to impersonate. It's, your app doesn't crash. You ask for the right permissions at the right time, and you don't ask for permissions that you actually don't need. Everything's encrypted, very important. Communication is safe. But what are the actual metrics, and is your app really safe? So there's such a big space, it's really unclear what it means. In the end, it's all of those points that I put on the screen, and many more. I'm sure I forgot something. But the important thing to remember is that you have to look at all the particular things and make sure that you have a good overview on, let's say, the attack vector and the results that an attacker could achieve when one of those vulnerabilities would actually be relevant. With most security breaches we see in the media or that end up in some really data breach, what we usually see, it's not a single vulnerability. The single vulnerabilities are usually kind of not very critical or medium critical. Most of the time it's really a sequence of small, minor vulnerabilities, and through the sequence and the attacker really gets access to the system. So the important message is look at all those things and have a good overview on where you actually are, where do you have vulnerabilities. As minor as they might be, it's important that you know them and can react on them once somebody else or some breach gets known that might have that particular vulnerability somewhere in its sequence. You should think about security right from the start. It's not something that you build your product and in the end you hire this security guy who will just add that as a feature. It's not possible. It's a process, and you have to execute it on every single step on the way. So, now we are coming to the more concrete topics, secure communication. Here I'm going to talk about the network communication. I suppose most of you guys have an app that communicates with some sort of an API, and also interprocess communication. It's particularly interesting, like deep linking and all those concepts. And then I would like to talk a little bit about data safety. How is data actually stored on the device? What does it mean stuff is encrypted? And how is it encrypted? And what is actually encrypted? And what are the, how can you leak data without you even knowing about it? So let's talk a little bit about the new application transport security enabled by default in iOS 9. Enforces TLS 1.2 on your server, and is by default the right thing. So if you just open a new project with iOS 9, you're covered. It's great. So nothing to add here, right? If you are a person like I am, I like to see my app communicate with the server. And I have a reverse proxy in my dev environment, and I'm watching what's going on. So you might recognize that piece in your plist. Who recognizes that? You're a bad person. And so am I, because I'm using this a lot in order to be able to see all the things that's going on. It just helps and makes me more efficient. But it's basically all those exceptions, so since all of you already know it anyways, basically bypasses the right thing. And who ended up with that piece of code in the App Store already? Yeah, we have some honest guys here. It happened to me as well. And either you have that piece of code in the App Store and you essentially disable all the nice security features, or you're being rejected right away anyways. So it really depends a little. It's not always, review is not always as thorough as it should be. So here I would really propose or like to share kind of a setup that is that allows you to be as efficient, but takes away that piece of code, that bad piece of code that you will eventually forget, that you will eventually check in, the reviewer will not see it, and that will end up in the App Store. So it's kind of part of a software development process that actually allows you to forget about stuff. The more you automate in that area, in the security area, the more habits, good habits you build, the less likely you will end up with this piece of bad code in the App Store. So instead of disabling ATS, you can keep ATS but tunnel it through, let's say, your local development machine with tools like S-Tunnel, burp-suit, and Charles proxy, and set them up correctly with certificates, and set them up such that they connect securely to your development API or production API, so that you can actually develop efficiently without all those hacks, and don't need to think about how to release this piece, which development and debug statements to disable once you release the app. So this one particular setup is actually that your app connects to your local environment on localhost actually, and your development machine then builds the tunnel to the API environment in a secure and totally regular manner. Another thing that I would like to talk about is SSL pinning. Who knows SSL pinning? That's awesome, many people. So instead of actually just, so it's one additional layer of defense, I would say, and it's really easy to use if you use like AF networking, for example. Just this one line, and you add your pinning, and AF networking will make sure that any kind of certificate that you have in your project is used and verified against. What it's actually doing is, instead of only trusting a certification authority, you limit the number of certificates that you trust to one particular or to a particular set of certificates that you know are yours or the ones from the API that you actually want to connect to. Why would you do that? Well, first of all, there are so many certificate authorities, and there have been a number of breaches where signing keys have been compromised. But there are also networks, like company networks and stuff like that, that actually enforce their employees, for example, to install tools that allows them to break open the SSL tunnel, to inspect traffic, and then continue to the outside. We are an app in the financial area. We don't want that. That's a decision that we made. The result is, of course, that in certain networks, our app will not function, will refuse to connect to our API, but that is a very conscious decision that we made because we think our data is sensitive and our clients should be protected from that, even if they're not aware about it. So if you're using SSL pinning and you add your certificate to your project, and for example use AF networking to enable as networking library, it's very easy to, actually in the previous slide, to define the SSL pinning, and there are certain modes that you can use. None, of course, I think it's clear. Public key and certificates are the two relevant modes. If you use the pinning mode certificate, the pinning mode is actually that particular certificate that is in your app. That means you have to take care of certificate expiration. If your server certificate expires, you have to also to ship a new app with the new certificate. If you use public key pinning, you can actually create a new certificate for your server, and as long as you use the same public key, the same certificate signing request, your app will continue to work, so you don't have to ship a new app. And you don't have problems with updating behavior. If you pin to a particular certificate, you have to catch that and somehow give the user feedback why she should update the app or why the app isn't functional anymore. The next thing is something that sounds very basic but is done incorrectly very often. That's HTTP basic authentication. The key point is where to store your credentials. Well, you should certainly not have your credentials, username and password somewhere in a code or in a shared preferences, in user defaults or in a plist, because everybody can just read it up, right? and look into the code and see it. You can store it in the keychain. That's perfectly fine. And if you use NSURL credential storage, that's basically a wrapper for that particular use case that actually stores the credentials in the keychain, and you are not really required to handle the keychain for it. So what it's actually doing is you can store credentials for a certain domain, can be multiple credentials also, and once you get an authentication challenge for your HTTP request, you can pass in the credentials object. So you don't even have to unpack it and read the username and password. You can just pass the credential object for that particular domain. And if you have multiple username password combinations for that domain, you will get a list of credential objects which you can then pick from. There are certain modes here. For example, you see NSURL in the credential. You have the persistence mode. It says here NSURL credential persistence for session or permanently. You can store them in different modes. So relating to network, secure network communication, I'm not talking about topics like CF-stream, NS-stream, multi-peer connectivity, and the vast number of networking libraries that are out there. One thing that is important is that all those concepts that I explained before, like ATS, SSL pinning, the authentication challenges, they don't apply to CF-stream and NS-stream. They apply to NS URL session and NS URL connection. So if you use those, make sure that you handle security differently. Multi-peer connectivity is a similar topic. By default, traffic is encrypted. There are different modes on how the traffic is encrypted, so have a look into that if you use it. And if you use some other third-party networking library, make sure that you look into those topics before, such that if you want to enable like SSL pinning, those things, that is actually easily possible and you don't have to work around the library, which would be not what you want to achieve with it. It should make your life easier, not harder. I would like to go on now with inter-process communication. Very famous URL schemes, for example. Who knows how URL schemes work? Great, so I can skip the first line here. Who knows the Xara exploit? Okay, not so many anymore. So it's actually more than a year old. And it's an exploit that basically takes advantage of the way how URL schemes are handled on iOS. You have your app supports a URL scheme, like my app here, for example, but any app could actually register for that scheme. And the way iOS handles it is that whenever this URL is called, the last app that registered for that domain is actually called. And there's no way that you can make sure that this is you. So how does an exploit work for that? Well, I just pick the app that I wanna attack. I figure out what's the URL scheme, and I offer the same URL scheme. And for a number of social engineering or whatever, I make users install my app, and as soon as those users actually click the link, my app will open instead of yours. And then I have a number of possibilities. I can impersonate you and ask for username and password. Same look and feel, users won't probably not notice, right? I can also use that scheme to exploit your Facebook login button. So if you use Facebook as a login option in your app, Facebook is using that exact scheme. So you call the Facebook app with a URL scheme, and once the user authenticated inside of Facebook, Facebook actually calls your app, also with a URL scheme, and you have to register a particular URL scheme for exactly that purpose, which is FB plus your Facebook app ID. If I figure out your Facebook app ID, Facebook is going to call me instead of you and pass me a session token for the user. So I'm going to get the user's friends and information. So if you use that, stop using it. Use universal links instead. This is something that Apple introduced with iOS 9. One of the reasons to mitigate the URL scheme hijacking problem. And it works differently. So instead of defining this URL scheme, you actually have to add an entitlement to your app. It's called associated domains. That's basically your website, for example. And on your website, you also have to put a particular file. It's the Apple App Site Association. And that file is signed with the private key of your SSL certificate, so Apple can validate it. So once once your app is installed and associated to that domain, and you browse that domain, iOS will automatically download that file and basically figure out how that domain is related to the app. So it's a little bit blurry here, but you can see inside the file you have the app that you actually want to trigger, and you also have the path. So the path, it means whenever you go to that domain with that path, Safari will actually trigger your app and pass in a UI activity object that you can then in your app delegate handle with this continue user activity method. And in there you can then parse the path and whatever kind of parameters you passed along that. This is much safer than the URL scheme. There are some limitations here. You actually need a website that you can associate your app to, because you have to serve that Apple app site association file. This wasn't necessary for the URL scheme, actually. URL scheme worked just without anything. But it basically makes the URL scheme hijacking impossible. There are other topics for inter-process communication that would be shared credentials, where you can store credentials. You log in on a website, and actually with the same file like I showed before with the universal links, you can make it possible that the app actually remembers those credentials. So you log in on a website, and then you forward it to the app, and your keychain actually remembers the credentials and logs into your app. UI activity, where you can share stuff. Extensions like the Today extensions, but also watch apps. Web app, all the JavaScript bridges. I'm not talking about those. That's a very particular topic in itself. And also baseboards. So with baseboards, I will we'll talk about it also later in the data leakage. Baseboard is very dangerous to actually leak data. So if you want to make sure that you're not leaking anything, always make sure to delete your baseboard. Now, I would like to move on to data safety, how to store data, or how is data actually stored, how to not leak data. There are different topics here, like the keychain to store small snippets of data, and the bigger topic is the data protection API that is actually used to encrypt files and works with the passcode of the user. I'm not covering databases here, like Core Data or Realm.io, but there's a session about Realm.io later, right? So keychain. The keychain actually encrypts data using the hardware key. We'll talk about the exact setup of the keys in the next slide, but for this context, it's just there's one hardware key that's actually device specific and only accessible by the hardware encryption, and this is what keychain actually uses. And there are different modes on how you can add stuff to the keychain and how you can retrieve stuff. Then there are a whole bunch of attributes. The italic one on the beginning here, it's the default one. So whenever you add something to the keychain and you're not specifying a mode, the mode is when unlocked. That means once your device is unlocked, you can access data, which is maybe not what you want. So just make sure that you know when the data should be readable, or if the data should be also synchronized to iCloud. So they are all the last four elements all have the device only word in them. That means this data is actually not synchronized to iCloud. It's only stored on the device. If that's what you want, be sure to use that. Don't use the keychain straight. Use some wrappers. There are nice wrappers out there that makes it much more simple. Don't use the default example code in the Apple documentation. It's kind of old. There's like Lockbox or Simple Keychain. There are various wrappers out there that make the task very easy. Now let me move on to the actual encryption key hierarchy. that we need in order to work with the data protection API. I already mentioned the hardware key that is used to encrypt the keychain. Now, there are a number of other keys, actually. The hardware key, together with the pass key, is actually used to create the class key. The class key is something that you can now use with the data protection API to specify how you want your files to be accessible. And there are different classes similar to what you saw before with the keychain, like once unlocked and all those different modes that you can specify when your file should be open. The hardware key actually also is used to create the file system key. The file system key encrypts the file system. So far, so good. And with the file system key, you can decrypt the metadata of a particular file. And in the metadata of the particular file, you will find the file key that allows it to you to decrypt the actual file. So encrypting of files is basically a two-step process. First, decrypt the metadata to retrieve the file key, then with the file key, decrypt the actual file and get to the content. So the file key itself is created with the class key and therefore includes the kind of permission that you want that file to have. Why is it done like that? If you think about a remote swipe, what happens with in a remote swipe? The one thing that happens is we throw away the file system key, we throw away the class key, and everything on the hard drive, on the storage, is actually just cipher. Nobody can read it. Why is it done like that? Because you cannot really achieve a swipe on a NAND flash. How do you do that? If you would need to set every single bit. It's a long process, and actually the firmware of those storage modules actually prohibit that, because otherwise it would be physically broken after a very short time of usage. So hardware would wear down without those mechanisms to prevent writes on the NAND flash, actually. So coming back to the class key, there are a certain set of those classes that I actually mentioned. It's the NS file protection complete. That's actually the safest option, and if you can use that, use that. Why would you not be able to use that? For example, if your app needs to access data in the background. If your app needs to access data in the background, you need to use NS file protection complete unless open. That means once you move to the background, you can still read and write to files that have been open while you were in the foreground. You cannot open any new file with that permission, but you can, of course, read and write all the other files that have no protection at all. And then there's also NS file protection complete until first user authentication. It's like the complete, but unlike a complete, it remains unprotected or readable after the user signed in for the first time, and that is actually the default one. So if that is not what you want, make sure that you use one of the others to increase your level of protection here. So how do you work with background tasks? If your app only works in the foreground, you're done. It's fine. You have nothing to do. But if you work in the background, you actually have to handle the changes in the permission stream. And you actually have two delegate methods for that. Data will become unavailable, and data did become available. So you can handle those changes there and make sure that you stop writing or reading from those particular files. In the context of the data protection API, it's important to know what is and what isn't protected and when is it protected. This is like the classes that I mentioned before. So it's just important to know if you use the default system, basically, after the first user sign in, your data is readable. Now, I would like to move on to data leakage. There are a number of issues related to that. It's like login. If you use NSLog, for example, your log entries just are not just on the console. They also end up in the data store. So if you either disable logs for your release builds or use logs with breakpoint actions in your dev environment, for example. So that means you can add an action to your breakpoint, and instead of looking at it manually, the breakpoint just is passed and this action, like writing to the console, is triggered. Also, HTTP caches are a common source of data leakage. Your caches are stored here in this file, and if you call this method remove all cache responses, this is actually not deleting that file. This is just removing the cache from the memory. If you really want your cache file being removed, you have to use that nice little snippet actually the file manager that really goes into that directory and deletes the file. Also snapshots. So when the application enters the background, a snapshot is being made with your screen. That is just for efficiency and to have once the app comes back, you have a screen immediately there and it just looks very nice. But you don't want the screen where you type in your credit card info in the file system of your app, because you can actually not delete those files anymore. They are, if you use tools like iExplore and whatever, you can just browse them and get that screenshot. And if you have a screenshot with the full credit card number, it's maybe not the coolest thing you should do, right? So make sure that you actually do some screen sanitation before your app actually goes to the background. You can blur parts of the screen, or you can do what we did in our app, just put a splash screen back on. So you can never get any information out of that. Other topics here are, as I mentioned, baseboards. There are actually two default baseboards. That's the regular one, and that's the baseboard find, of type find. So everything that you enter in a search bar is actually automatically put in the find baseboard. Nobody's actually using it. But if you have a search bar in your app and users enter some text there, that text is in the find baseboard. And if you don't want that text to be available to other apps, you should manually delete the baseboards, and just the same with all the other baseboards. And also, if you use custom baseboards, also make sure to delete those before you leave the app. I mentioned user preferences where, like, you could store passwords, right, which is not a good idea. Key logging and autocorrection. So if you use, let's say, custom key or custom keyboards, and not you use custom keyboards, but your users might use custom keyboards. So if for text fields where you expect sensitive data input, you should think about disallowing that, because they might send data to some server or to some other system. And of course, SQL stores, like you can use things like SQL Cipher to have core data encrypted, or Realm.io also offers an option to encrypt data. So given all those things, how do you move on and define, well, or get a confident feeling whether your app is secure or not? Well, there are tools that help you, like the OWASP Mobile Top 10. OWASP Top 10 is something that many of you probably know for web development, and they also have something for mobile development now, like improper platform usage, #1 here. Insecure data storage, we covered that. Insecure communication, insecure authentication. So here you basically have a checklist to go through that gives you a good feeling on where you are. But of course, internal and external testing is very important. And in the end, you need also to to have a good idea of what actually would happen if data if my app would be breached, what options do I have? What can I do? Disable the app, disable the API, how critical is information that can leak, how do I inform my customers, how do I handle the situation? Because there's this saying, so against a sufficiently skilled, funded, and motivated attacker, every app is vulnerable in one way or the other. So just be aware of that there's no 100% guarantee. Secure organizations. How do you build a secure organization? Well, first of all, stay informed and adhere to publicly available design guidelines, like OWASP that I showed you just a slide before, but there are a couple of others. Stay informed and subscribe to security mailing lists or follow people on Twitter, and train your employees or yourself to make sure that you are aware of the latest breaches. Test your system. Do it yourself or pay somebody to do it. Depends, of course, on the criticality of the data that you have in your app. I mentioned before, we as a financial institution actually paid a security company to do it. Also because we need a report. And establish best practices in your software development process, like peer reviews, but also continuous education and training on new features, new platform features, and recent attacks for your developers. There are a couple of tools and sources that I can recommend to continue reading and using, so for your reference. And I'm happy to take questions if there are any.
Thank you. All right, so do we have any questions? Here we go. First one, second one.
Hi, thanks for the talk, very interesting. Two questions actually, but one is very short. Is there any way to get around with that Facebook app URL scheme? Because, well, my users want to log in with Facebook. Can I prevent Facebook using that URL? I'm not aware of that, if that's possible. And another question, if you're doing SSL pinning, a lot of bigger companies like Google are now using certificates that are valid for like 90 minutes or 3 days or something like that. That's kind of goes against SSL pinning. What is the best way to like have a mix of both, like have a good security, but also not need to deploy an update every other day?
Yeah. Your first question regarding Facebook, I'm not aware that there's another option actually to do it. But I didn't use it, let's say, for the last 6 months, so maybe there was an update. By the time I implemented that, that was the only way, and you were first to do it. So bad luck here. That's some of the trade-offs that you will constantly have to make, right? There's always a decision that you have to make. Is it important for my business, and what could leak? And is the trade-off okay for you? And then you can do it, right? Regarding the certificate, in that case, you should not pin to a particular certificate, but to the public key of the certificate. So you can recreate certificates as long as you use the same signing request. All of them will have the same public key. So you don't need to redeploy and resubmit the app every second day.
All right. There was a question over there, and another one here. Yeah. Wait. I think the gentleman over there was first. Do we have another mic in the crowd? Seems like not yet. All right. Cool. Thanks.
That's fine. Thanks. Thanks for the talk, first of all. And second, just not a question, but a fine remark that we found at our development process. So there are two great things, which are file system protection and core data. And the third thing is the push notifications. So when they all connect, it makes a very explosive combination of a default file system access, which is unlocked until first open, and core data using it, which means if your device was never unlocked and your app is running on the background, you cannot access the core data store, and you are never even setting any permissions on file system, and this is by default. And when you try to open the core data store until your device was first opened, it gives a very generic error, which means I cannot open the store. And in general case, we had this database loss bug that happened to users who just turned on their phones and never unlocked, and they get the push notification that activated the app. App was trying to access core data store. We couldn't open the core data store, so there is like no choice for the app rather than deleting the database and recreating it again. So just for people who use core data, this is a very nasty bug that we were fixing for 3 months or something. Thanks.
That's very interesting. How did you fix it?
Oh, we were just observing now the notifications when the file system becomes available, and we do nothing until we actually able to access the core data store, which is encrypted by file system.
Okay.
Thanks.
Thanks.
Thank you. And our question is,
thanks for the talk as well. My understanding of ATS is that this is a good way to authenticate that the app is talking to the right server. But what about, I realize this kind of gets outside of the scope of iOS, but obviously you'd have to build into your project. What about authenticating that the app is your first party app from the server's perspective? Does ATS also cover that, or do you have any thoughts on that?
So you mean from an API point of view, actually checking that the request is coming from your app and not from somebody else? Right.
So you have the example of username and password with HTTP basic authentication, but that's for the user rather than the app, right?
Yeah. That's a tricky question. So if you have authenticated access to your app, that's kind of covered, right? Because you have to authenticate before you can are actually able to use it. But many times apps are or APIs are actually semi-open. So they do require some sort of a token to actually use it, but how you get the token is a different question, right? So if you, for example, just have your API token in your shared preferences, it's very easy for somebody to just get that token and make the API calls, so you have either you do some silent login in the background that actually gives you some sort of a token or a session token or something of that sort. Otherwise, I wouldn't be sure how to do it actually. Yeah.
Right. Last question. Whoa. All right. So 3, I see at least. Like, okay, last 3 questions. 1, 2, 3. Right.
Hi. You said with HTTP basic authentication, you can store the credentials in the keychain, but to store them in the keychain, you have to have them somewhere in clear text, right?
Here, I suppose that the user typed them in, for example, if you have some login form, right?
Okay.
Yeah. But if you don't, so that relates a little bit to the question before, right? If you want to deploy your app or to ship your app with some sort of credentials included, right? This is a difficult task, right? So
there's no real secure way to do this, right?
Not that I could think of, no.
Okay, thanks.
Hi. Is the I'm not sure where core data and Realm store their files and with which settings, but I'm assuming you can use document protection with them. So what additional value is there in using additional encryption for them?
So the files for core data, for example, they are secured with the data protection API. And if you have a passcode, it has the class that the other person who asked a question before mentioned. I don't remember. If you don't have a pass key, it's just with the file system key, right? that is, of course, if you now have your app and you put in the USB cable and you open iExplore, you can just get the file and see the SQL statements, right? There are other tools to actually encrypt that. As in Realm.io, it's a setting where you can basically have that encrypted. And for core data, there are libraries like SQL Cypher that you can use to actually encrypt the core data database. And then it's basically encrypted in at runtime. So you can still just execute your queries against the database.
Thanks.
Okay, last question over there, and yeah.
My question is regarding custom keyboards. You said that you are, or that we are able to disallow custom keyboards from being active in specific text fields. Is that possible? I'm not aware of it.
So I didn't really use it yet, but there's settings for password fields, like, for example, sensitive data, and for those fields, the custom keyboards wouldn't be used, right?
For other fields, if I can I define it for
For
a non-password field?
For generic fields, I'm not sure actually if I can use it for any kind of field.
Thanks.
All right. Thank you very much, Andreas, again.
Thank you.